In this tutorial, we want to kind of figure out how we can use the given information like percent composition data, perhaps the empirical formula, the molar mass of a compound, to help us find the molecular formula of a compound. So when you determine the molecular formula, there's two things that are really needed in order to be able to find that out. And that is the empirical formula and the molar mass of the substance. And so we learned in the previous tutorial the steps required to determine the empirical formula. And once you have that empirical formula, you can find its mass. And the reason we want to do that is because we want to see how many empirical formula units are within that molecular formula. So if we know the molar mass of the molecular formula, or the molar mass of the compound itself, we can divide it by the empirical formula mass to get this R value. And what this R is it represents how many empirical formula units there are within a given molecular formula. Once we know what that value for R is, we can simply multiply that by the subscripts in the empirical formula to find out what the molecular formula is. Let's take a look at an example, and we'll hopefully kind of shed some more light on these key steps here. So we are given the percent composition data, and we are also given, not necessarily explicitly, but we have the mass of 1 mole is 90.1 grams, and so we have the molar mass of the compound. And so we are asked to determine the molecular formula. And so if you recall the steps from the empirical formula tutorial, the first thing we need to do is take this percent composition data and turn it into a form that we can work with. And so we do that by assuming we have 100 grams. And therefore we get these amounts, and we can then, secondly, find the number of moles of each. And then what we want to do with the number of moles is see basically what the ratio is between the elements involved in this compound. So we know we have carbon, hydrogen, and oxygen. And basically, if we divide by small, as we talked about in the previous tutorial, and so we're going to divide by our smallest number of moles, which is 3.33 moles, we get this ratio of, for every 1 carbon, we have 2 hydrogens and 1 oxygen. And so now we have the empirical formula, and we can use that to help us find the empirical formula mass. And quite simple, all we're doing there is taking, basically finding the molar mass, if you will, of CH2O. And so that would be 12.0 grams per mole, and then we get the 2 times 1.01 for hydrogen, and then plus 16 for the oxygen. And so each empirical formula unit has a molar mass of 30.03 grams per mole. And so now we want to see how many of those units occur in the molecular formula. And so we take the molar mass that was given, the 90.1 grams per mole, and we divide it by our empirical formula mass, which we just figured out, and we see that we get this nice whole number of 3. And so there are 3 units, or 3 empirical formula units in the compound, or in the molecular formula, which means that we need to multiply the 3 by the subscripts in the empirical formula, which gives us C3H6O3. And a couple of ways to check our answer here. So the R value every time should be a whole number, right? You should always have a whole number of empirical formula units in your molecular formula. The other way to check your answer is we could find the molar mass of C3H6O3, and it should be 90.1 grams per mole. So hopefully now you see that finding the molecular formula really is just an extension of finding the empirical formula and applying your understanding of the relationship that exists in between the empirical formula and the molecular formula of a substance.